So if you're looking at it, you're like, that's not the actual graph. Well, it's pretty close to the graph. So hang out with that. This is going to help us with the shading. So those of you who've struggled with shading, the and, the or, the inequality symbol, how everything moves, so we're going to get that cleared up right now. All right? I hope that's our plan. So what I want you to do, we're taking a look at this, and we note that this graph has a 0 of 2 and a 0 of 4. Now I'm assuming everyone knows that this is 2 and this is 4 because this times this has to equal 0 if we pretend this is an equal sign. Everyone good on that?
Yeah.
Okay, so it crosses at the ordered pair 2 and 4. Now what I want you to do is just kind of ignore right now the actual graph and just think of this as a number line. Let's put it on a number line. There's 2 and there's 4 on a number line. That breaks your number line into 3 different regions. We clear on that? Okay. Breaks it into 3 different regions, and this region right here, there's a number in between, it's 3. There's a number over here we could use, which would be like 5, and we could use an easy number over here like 0 or 1 or whatever. All right? To figure out how you actually write your answers, because the questions I was getting is like, how do I know, like when I put my inequality symbol in, how do I know which way it's pointing with these numbers? To figure that out, let's just graph it on a 2-dimensional grid. It's a less than symbol. These would both be open circles. And we just test the points. So if I put 0 in, so I'm going to test 0. 0 minus 2 is -2. 0 minus 4. And -2, -4 gives us 8. Is 8 greater than 0? Yes, that is true. That means at this point, right here on this region, it is a true statement when we test it. Okay? When I test 3, what's 3 minus 2? 1. 3 minus 4? -1. 1 times -1. That is -1. Is -1 greater than 0? No, that is a false statement. And I put 5 in. What's 5 minus 2? 3. 5 minus 4? 1. 3 times 1? 3. Is that greater than 0? Yes, that is a true statement. Therefore, my shading, I have to shade all over all solutions. That is my shading. Now, if I apply that to my actual graph here, this number line right here is this number line right here. They are the same number line. Okay? Therefore, this is an open circle, or this would actually be a dashed line. It should be a dashed parabola based upon what we have. So we put solid, but that was the quick making of the worksheet. And this shading happens on the outside of that number line, which means we're shading all this junk out here on the outside. The other thing it means, and some of you are like, I didn't have problems with the shading, I had problems with the symbols. Well, that's good. Here's 2, x, and 2, and I am shading that way. X and 4, I am shading that way. And this is what type of graph, and or. Or, and you should know it's an or because these two things cannot exist together. X cannot be less than 2 and greater than 4. That is not possible. Right? If I say, hey, pick a value pick a value that is less than 2 and greater than 4, you'd be like, you know, smoke starts rolling out of your ears and stuff. Okay? That is how we shade. All right. Why don't you try this one? Using the same process. Go ahead and compare with your neighbors, your groups.
Inside, yeah.
Okay. That is what I have. Okay? Is that what everyone got?
Yeah.
So the shading actually happens inside the parabola. Your inequality, when you're done, should be x is greater than or equal to 1 and x is less than or equal to 3, which you could write as that right there. Now remember, an and graph you can write in that compound format, Or graphs you cannot, because you're stating that two things are being true when you do that.
So,
yeah.
Inside the parabola, it's always an M, and outside it's always an R?
Nope. Okay. Yeah. So the next piece I want you to go, you could practice more of this if you want later, just for fun. All right, but go ahead and turn your paper over. You got to be careful because it almost looks like it's upside down, but you're like, hold on. The numbers aren't upside down, so you got to turn the right side up. I want you to try the first one here now. All right, there we got it. Have you got it? Okay. So notice the negative sign. All those values we had prior, it just makes them all negative. So it makes those a false statement. So that was what was confusing people, I think, is, you know, when we had the symbols, we were like, well, this symbol is and, this symbol is or, but then when we flip it upside down, it changes things around. So it's easier if you test them like this, and really when you get to pre-calculus, that's how you're going to figure out your regions anyway. So that's kind of a good preparation for next year, doing that. Okay? All right. Now, do you think you got it? Emily, question? Correct. Yep. No, this is an and situation. Yeah, so at the end, we have 2. So we have x is greater than 2 and x is less than 4. Oops, not equal to, just less than 4. If the a value, the graphs are switched. Right, so this was our previous one, right? The other one we did, where we had it shaded on the outside. And so all we've done is change the a value. So between those two graphs, the only thing that's changed is our a has become negative here. Okay, so
it only affects how you're solving if you were doing it the way where you look at the way the arrow's pointing?
yes. Yes. Yeah, nothing. If you are testing your points, that's why I'm trying to have you go through this process. If you are testing your points like this, you shouldn't have any. If you go through and just test your points, you shouldn't have any problem with how your inequality is written at the end. Okay, this one we've shaded on the outside, which means we have x is less than 2 or x is greater than 4. And that's shading this way. This one we've shaded in between, so that's x is less than 2 or greater than 2 and x is less than 4, which we could write in that format as well. Okay? All right. I'm hoping that's a little clear. More clear. Yes? No? All right.